This lesson is entitled Solving Business Problems Using Algebra in the Graphing Calculator by Dr. Archie Earl. This function represents the number of subscribers to a cable television company. That's what f of x represents in this function. And f of x is the same as y. And x represents the year. For example, 1970, 1971, 1982, 2015, 2025, and so forth. So this is the function that we're working with. And as indicated, f of x equals y, which represents the number of subscribers to the cable TV company. And x represents the year. For example, x equals 0 is 1970. X equals 1 represents 1971. X equals 18 would represent 1988, and so forth. This is the question we have to answer. When will the number of subscribers reach 49 million? Now, y here, the number of subscribers is in millions. For example, if I get y equals 1, that represents 1 million. If I get y equals 22, that represents 22 million. So here we're talking about 49 million. So really, I have to substitute 49 in the equation for y in order to find x, the year, which is what we're looking for. It says, when will the number of subscribers reach 49? So the question is when. That means in what year? In what year will the number of subscribers reach 49? So there are two ways we can solve this problem. We can solve it using algebra, or we can solve it using the graphing calculator. And we might decide to solve it both ways, and one can be a check against the other if you solve it both ways. So first of all, let's solve it using algebra. If you solve this problem using algebra, first of all, you would solve the equation for x. Because the equation is already solved for y. Y is the same as f of x, so we have y equals. So we have to solve the equation for x, or get x by itself on one side of the equation. After we solve the equation for x, then we substitute 49 in the problem for y, because the 49 represents the number of subscribers, and that's what y represents. So the first thing we have to do here, in order to solve this equation for y, is to substitute y for f of x. So that would give us y equals 75.5 over 1 plus 14 times 0.8338 raised to the x power. So we would have a y equals here. And then y is the same as y over 1. So we can write y as y over 1. And that's what we've done here. Here we have substituted the y for the f of x, and we wrote the y over 1. And then we can do what a lot of students call cross multiply. Multiply the y times this, and multiply the 1 times the 75.5. So when we do the cross multiplication, y times this will give us y times 1 plus 14 times 0.8338 raised to the x power. And that's what I have here, y times that, using cross multiplication. And then we will multiply the 75.5 times 1, which will give us 75.5. So most students call that cross multiplication. Of course, the technical term for it in mathematics is multiplying the means and the extremes. So that's what we get here when we cross multiply, as most students say. And then, of course, we want to solve it for x, so we want to get x by itself. So the next thing we do is divide both sides by y. So, and that's what I've done here. I've divided both sides of the equation by y. So I divided the left side by y and the right side by y. Of course, on the left side, the y is canceled. So I end up with 1 plus 14 times 0.8338 raised to the x power. And that's what you see in my next step here. This is what I get on the left side. On the right side, I get 75.5 divided by y. But I still don't have x by itself. So the next thing I would do, what do you think I would do next here? What would I get rid of on the left side of this equation? If you say get rid of that positive 1, you're right. That's what I get rid of next. So to get rid of a plus 1 or a positive 1, I subtract 1 from both sides of the equation. So that's what I've done in the next step. I subtracted 1 from both sides of the equation. And as you can see there, on the left side, the 1's cancel. I get 14 times 0.8338 raised to the x power equals 75.55 over y minus 1. So now I still don't have x by itself. So what do you think I would get rid of next on the left side of the equation trying to get x by itself? If you say get rid of that 14, you're right. That's what I would get rid of next. So the question is now, how do I get rid of that 14? What do I need to do to both sides to get rid of that 14 on the left side of the equation? Stop the tape if you want to and think about it. See if you can figure it out. And then start the tape again and see if you got it right. I would divide both sides by 14. That's what I would do to get rid of that 14, because this is multiplied by 14. So to get rid of it, I divide by 14. So this is what I get when I divide both sides by 14. On the left side of the equation, the 14's cancel. So I end up with 0.8338 raised to the x power. On the right side of the equation, nothing cancels, so everything just remains the same on the right side of the equation. And that's what I have in the next step, as you'll see. I have 0.8338 raised to the x power equals 75.5 over y minus 1 over 14. So as you notice here, I still don't have x by itself. So I got to get rid of that. I got to get that x out of the exponent. That's what I have to do, get that x out of the exponent. So stop the tape, see if you can figure out what you do to get the x out of the exponent, and then start the tape again. See if you got it right. All right, so I hope that you're taking a look at that. What I have to do to get that x out of the exponent, I have to take the log of both sides of the equation. And I can use the common log or the natural log. So I use the natural log in my problem. Remember, on your calculator, you can do common logs, which is base 10, and you can do the natural log, which is the natural base, base e. So you can use either one of those. The final answer will still come out the same. But I use the natural log to get that x out of the exponent. So that's what I've done in the next step. I took the natural log of both sides of the equation. Now, when I take the natural log of the left side of the equation, the x moves down beside the ln. So this is going to become x ln 0.8338. And this is the one of the rules of logarithms that we're using here in order to get that x of the exponent. When you take the log of a number to an exponent, the exponent comes out front here, and then you just have the log of the number. So that's what we have in the next step. I have x times ln 0.8338 equals ln of everything that we have on the right side. So that's what I have in my next step. But I still don't have x by itself. To get x by itself now, I got to get rid of that ln 0.8338. So what do I do to both sides of the equation to get rid of that ln 0.8338? Stop the tape, see if you can figure it out, do it, and then start the tape again, see if you got it right. Okay, what you need to do here is divide both sides by ln 0.8338, and that will get rid of this ln 0.8338, and x will be by itself. So that's what I've done in the next step. In the next step, I divided both sides by, by ln 0.8338. You see, divide that side by it, and also divide this side by it, ln 0.8338. You see, you divide both sides by that. On this side, it cancels, and I end up with x by itself, which was my objective. When you want to solve an equation for x, you want to get x by itself on one side of the equation. So that's what I've done here. You can see the result is what I have there. I have x by itself. Now all I have to do is substitute the 49 for the y, plug it into my calculator, and then get the answer. So that's what I've done here. I plugged in the 49, and then I plugged everything into my calculator, and I got x approximately equal to 18. So usually in these types of problems, we round up. So if I got 17.2, I would round it up to 18. If I got 17.7 or 8 or something like that, I would round it up to 18. So my answer for x is 18. But now I have to convert that into a year. The number 0 represents 1970. 0 corresponds to 1970. X equals 0 corresponds to 1970. So that means that x equals 18 would correspond to 1988. So all I have to do is just add the 18 to the 1970. And that gives me my year, which is what I was looking for. The when represents the year. So the answer to my problem would be 1988. And as you can see here, you get the 1988 by adding the 18 to the 1970. So that's how you solve this problem using algebra. Using algebra, you would first solve the equation for x, and then substitute the value that you have for y into the equation, and simplify that and use your calculator in order to get the natural logs and what have you.